let's talk about the graph of the absolute value parent function. But first, let's just talk about the graph of y equals x. Now the easiest way to graph this for me is just to notice that whatever x is, y is going to be also. So for example, when x is 2, y will also be 2. And when x is 0, y will be 0. How about when x is 5? Y will also be 5. And what about when x is negative 2? Well, y will be negative 2. When we graph this, we can see it creates a line, and the line has a slope of 1. That's consistent if we think of this as slope-intercept form. Y equals mx plus b. Up here, the slope is 1, and the y-intercept b is 0. So that's why we have this line. Now let's think of the parent function for absolute value. What if we were to graph y equals the absolute value of x? Now this looks very similar to y equals x, except for this absolute value sign. Let's see how that changes things. Over here, in quadrant 1, when x is positive, y is still going to be positive and the same thing as x. So for example, when x is positive 2, y is positive 2. And when x is 6, y is 6. But what about when we talk about negative x's? When x is negative 1, the absolute value of negative 1 is positive 1. So we have the coordinate negative 1, 1. What about when x is negative 3? When x is negative 3, y is going to equal 3. Graphing this will end up looking like this. So over here it matches the graph of y equals x. But the graph of y equals x went down into quadrant 3 here. It's being reflected up here because now every negative y is going to be a positive y instead.